The world of cryptocurrency, it's constantly exciting, right?
Mm,
But it can also feel incredibly well fragmented.
definitely. It's like a whole collection of separate digital islands.
Exactly. You've got Bitcoin, sort of the bedrock, standing over here. Then there's Ethereum, this huge, bustling continent, DeFi, NFTs everywhere.
Yeah.
And then scattered around, this whole archipelago of others, Solana, Avalanche, Binance Smart Chain, each one its own little world, its own ecosystem.
It really does remind you of the early internet, doesn't it?
It absolutely does. Back when you had those walled gardens like AOL or
Mm.
Prodigy, or remember trying to send an email from Hotmail to like a university account?
Oh, yeah. Clunky is the word. Just systems not designed to talk to each other directly.
And that disconnection, that fragmentation, it's not just, a small hassle. It feels like a really fundamental barrier.
It absolutely is. It limits what blockchain tech can really achieve its full potential.
And maybe critically, it slows down wider adoption, right? Getting mainstream folks and institutions comfortable.
Exactly. That friction is a major hurdle.
So for today's deep dive, we are plunging headfirst into this really complex, but honestly fascinating world of blockchain interoperability.
Yeah, it's a crucial topic.
Our mission is pretty clear. We want to unpack this fragmentation problem, look at the consequences, which can be pretty costly, and then explore three really groundbreaking technologies.
We're looking at IBC from Cosmos.
Right, the Inter-Blockchain Communication Protocol. And then Polkadot with its whole parachain setup.
And the Interledger protocol as well, which is a bit different.
Yeah, a different angle. Each one is working, in its own way towards a more connected blockchain future. We'll try to cut through the jargon, hopefully give you some surprising facts, and really help you feel well informed on this. It's critical stuff.
All right, let's really try to unpack this. What exactly is blockchain interoperability? It sounds technical, maybe a bit academic.
It does, but the core idea is actually pretty simple.
Okay.
Simply put, it's about one blockchain being able to talk to, understand, and crucially transact with another blockchain directly, natively, without needing something in between.
Exactly. Right now, most blockchains are like isolated systems, digital nations almost, each with its own rules, its own tech stack, proof of work, proof of stake, whatever it might be.
And its own ecosystem of apps and users.
Right. And the basic challenge is they just can't natively communicate or share value without some kind of intermediary layer.
Let's go back to that early internet analogy again, because I think it really helps.
That's a good one.
Imagine if sending an email meant not just using a different service, but maybe even a different computer, a specific ISP. And then you just had to hope it could somehow reach someone on a totally different system not designed to speak yours.
Yeah, it felt limiting, clunky. Like you said, that's kind of the challenge we're seeing in blockchain right now. A hurdle to just seamless interaction of different languages with no universal translator. And it's truly remarkable how this isolation, this fragmentation, it really impacts everyone. From, the everyday user trying to do something simple to a really experienced developer trying to build something new. For users, it often means these incredibly complex, sometimes really frustrating experiences.
You mean like trying to move assets between chains?
Exactly. If you want to move assets or maybe use data from Ethereum on, say, a DeFi app running on Solana, you suddenly find yourself dealing with these things called bridges.
Or wrapped tokens. I hear that term a lot.
Right. Wrapped tokens. So you might take your Bitcoin and create a wrapped version of it on the Ethereum network, like WBTC, or wrapped Ether on Binance Smart Chain.
Which sounds complicated.
It often is. It involves multiple steps, maybe different wallets, different fees, a steep learning curve. It's confusing. It can feel intimidating.
And probably risky sometimes.
Definitely risky sometimes. And frankly, these processes are a big reason why casual users just shy away from cross-chain stuff. Imagine you find a cool DeFi app, but your money's on another chain. Suddenly you're in this multi-step, opaque process. It's a huge barrier to entry.
Makes sense. And for the developers building this stuff?
Well, it severely limits their flexibility. It limits the composability that blockchain is supposed to be so good at. That idea of different apps snapping together like digital Legos.
Right, building on each other.
Exactly. If a developer builds on Ethereum but wants to use a feature that's maybe cheaper or faster on, say, Avalanche, they face huge hurdles.
They can't just plug it in.
No. They might have to rebuild large parts or use these workarounds that are often clunky, maybe not very secure. It stifles innovation because you can't easily mix and match strengths across networks.
So looking at the big picture, this fragmentation is really holding things back.
It significantly slows down real-world adoption.
Yeah.
All this friction, the added risk,
Yeah.
it just makes blockchain less appealing for the mainstream use cases we need to see for this tech to really take off.
And this is where it gets, well, not just interesting, but genuinely alarming. The current situation isn't just inefficient, it's proven to be really dangerous.
Yeah, the security aspect is huge.
We're not talking small glitches here. The numbers, they're pretty stark. Since 2021, something like $2.5 billion has been stolen from cross-chain bridges.
$2.5 billion, that's staggering.
It's not just a number, right? It points to this massive security vulnerability. It really undermines trust in the whole space.
Absolutely. It shows that these bridges, which are often centralized or rely on, say, a small group of signers,
Built high SIGs, yeah.
right, or oracles that can be manipulated, they're just prime targets for attackers.
Well, every time one gets hacked, it's not just money lost, it damages confidence. It proves the point. These fragmented systems force us into using insecure pathways.
Paths ripe for exploitation.
Now think about the scale here. There are, over 20 major blockchain ecosystems operating largely independently?
At least. Probably more if you count smaller ones.
Try to get your head around that isolation. Imagine using the internet if every website needed a different browser, a different login, and couldn't share any info.
It would be unusable.
That's kind of where we are in blockchain, moving from a dApp on one chain to a game on another. It's a headache. Complex steps, real risks involved.
And for the user trying to navigate this.
The stats are concerning. Apparently, 70% of new users struggle with cross-chain operations. 70%.
Wow. That really puts it in perspective.
It raises that critical question, doesn't it? How can blockchain ever go mainstream if just moving stuff around is so complex and risky for the average person?
Yeah, it's a fundamental usability problem.
And the deeper implication, it's profound. This fragmentation isn't just some technical hurdle developers will fix eventually. It's actively stopping blockchain from being as easy to use as, say, online banking.
Even though blockchain has these amazing inherent benefits, security, transparency, immutability.
Right. The big promise of this open, secure financial system, it's being held back by these basic communication gaps.
Okay, so it's a big problem. Expensive, risky, slowing things down. How are people trying to fix it? Well, one major contender with a really interesting philosophy is Cosmos.
Cosmos, yeah. Their approach is quite unique. Because Cosmos isn't really a single blockchain itself, is it? It's more like a network of networks.
That's the perfect description. It's designed as an ecosystem of independent, sovereign blockchains, self-governing.
But they're designed to connect.
Exactly. They connect through shared protocols. Think of it like a federation. Each state has its own laws, its own autonomy.
But they agree on common rules for, say, trade and travel between them.
Precisely. It allows for diversity and specialization, but still enables communication and value transfer across the whole network.
And the core engine making that happen is IBC.
Yes, the Interblockchain Communication Protocol, or IBC, that's where the magic happens, so to speak.
So how does it work? Is it like another bridge?
Not quite like the bridges we were just criticizing. IBC acts more like a secure, trustless highway between these independent chains.
Okay, a highway. What travels on it?
More than just tokens. It allows value, so yes, tokens, but also arbitrary data and even complex contract calls to move securely and directly between chains.
And the trustless part is key, right?
Oh.
Given the bridge hacks.
Absolutely crucial. That's what really sets it apart. It doesn't rely on a third-party intermediary you have to trust or a small group of signers.
So no single point of failure like those bridges.
Exactly. Instead, it uses sophisticated cryptographic proofs. Essentially, the chains verify each other's state directly.
How does that work in simple terms?
Think of it like chain A cryptographically proving to chain B that a specific event happened on chain A. Chain B can verify that proof without needing to trust anyone else. It ensures the transaction is valid on both ends.
So it cuts out the middleman entirely.
Completely, which addresses that multi-billion-dollar vulnerability we talked about. It's a significant security leap. Like two countries inspecting each other's ledgers directly, no external auditor needed.
And what's really cool about IBC is its modularity, right? It's flexible.
Hugely flexible. It's not a closed club. Any blockchain built using the Cosmos SDK, their toolkit for building chains.
Right, the software development kit.
Or even chains that aren't built with the SDK, but can adapt to use specialized light clients. They can basically just plug into this IBC network.
Because the developers get a lot of freedom, build your own specialized chain, then connect it up.
Exactly. Optimize for your specific purpose, maintain sovereignty, but still tap into the wider ecosystem.
And this isn't just theoretical, is it? People are actually using IDC.
Oh, absolutely. It's not just a white paper. IBC currently processes over $1 billion in cross-chain traffic every month within the Cosmos ecosystem. It aims to bring EVM compatibility, the Ethereum virtual machine, to Cosmos chains. So smart contracts built for Ethereum could run easily within Cosmos. That makes bridging assets and apps to Ethereum much simpler.
Sort of creating on-ramps and off-ramps.
Exactly. The long-term vision is definitely to extend this secure IBC highway to connect to those major external chains too, probably through specialized secure gateways.
Can we look at some real examples? What's being built using IBC today?
Absolutely. Let's bring it to life. A great example is Osmosis.
The decentralized exchange.
Yes, a leading DX in Cosmos. It lets you seamlessly swap tokens from multiple different Cosmos chains, all directly via IBC. No wrap tokens, no external bridges needed for those internal swaps.
And it handles significant volume.
At its peak, it was handling over $300 million in daily volume. Shows how fluid assets can be within that ecosystem.
Okay, what else?
There's secret network. Their focus is privacy.
Privacy on the blockchain. How does that work with interoperability?
Well, they add privacy features to smart contracts, keeping transaction data encrypted, but they still maintain full interoperability via IBC. So you can have privacy where needed, but still interact with the wider, transparent Cosmos world.
Interesting combo.
Then there's Akash Network. Think of it like a decentralized Airbnb for cloud computing.
Decentralized computing power.
Exactly. And they use IBC to let people pay for that computing power using tokens from different Cosmos chains and manage deployments across the network. Very cool use case.
Making cloud resources more accessible and maybe cheaper.
That's the idea. And one more, Celestia. This one's a bit newer. A modular data availability layer.
Okay, what does that mean?
In simple terms, it specializes in providing a secure, scalable place for other blockchains to store their transaction data, like a data backbone.
So other chains can offload that work?
Right. Celestia uses IBC to offer these data solutions to connected chains, letting them focus on their main job without getting bogged down managing massive amounts of data. Crucial for scaling.
So these examples really show the specialization, don't they? Chains doing one thing really well, but staying connected.
Precisely. They keep their independence, but leverage the whole ecosystem's strength through IBC. It creates this powerful network effect. It's a really compelling vision for how a decentralized internet might work.
Okay, so that's Cosmos and IBC focusing on sovereign chains connecting. Now let's shift gears and look at Polkadot. It takes a fundamentally different approach, right?
Completely different philosophy, yes.
Yeah.
Equally powerful, but different design choices.
While Cosmos connects chains that secure themselves, Polkadot was designed from the ground up as a multi-chain network with shared security.
Shared security. That's the absolute key differentiator for Polkadot.
How does that work? There's a central chain.
Yes, at its core is the relay chain. And this isn't just like a coordinator. It actually handles the consensus and the security for all the chains connected to it.
Okay, so the relay chain is the security hub.
Exactly. And then connected to it, you have these specialized blockchains called parachains.
Parachains. And the crucial point is they inherit security from the relay chain.
They automatically inherit and benefit from the relay chain's overarching security. Your analogy earlier about the power grid was good.
Right, the central grid supplies power to many houses.
Yeah. Each house, parachain, might have its own unique purpose, its own appliances, but they all draw power security from the same robust central grid relay chain.
So parachains don't need to worry about building their own security from scratch.
Correct. They don't need to recruit their own validators or bootstrap their own economic security. They lease a slot on the relay chain and boom, they're secured by the entire network's validators. It's a huge advantage for new projects.
And how do these parachains talk to each other within Polkadot?
That happens through something called XCM, which stands for cross-consensus messaging.
Cross-consensus messaging sounds fancy.
It enables seamless, native communication between parachains. And here's the kicker. It allows for direct, trustless interaction without needing wrap tokens or external bridges within the Polkadot ecosystem.
So interoperability is baked in from the start.
It's baked into the very architecture. If you're a parachain, you can talk to other parachains. That's a massive selling point if you want inherent interoperability from day one.
Let's break down the core features then. Shared security is number one.
Definitely.
Yeah.
Reduces the burden on individual chains massively.
What else?
Parallel processing. This is a big scalability win. Transactions can be processed simultaneously across many different parachains.
So the network gets faster as you add more chains.
Essentially, yes.
Yeah.
The overall throughput increases. It's not bottlenecked by one single chain trying to do everything. It's like adding more lanes to the highway.
Makes sense. And the messaging.
Seamless messaging via XCM. It's not just about moving tokens. It means a smart contract on parachain A can directly call a function on a smart contract on parachain B.
Wow, okay. That allows for really complex interactions.
Highly composable dApps that leverage the strengths of multiple specialized chains. Think DeFi protocols using features from a privacy chain or an identity chain, all seamlessly.
And finally, the built-in interoperability.
Right. Once you're connected as a parachain, you don't need extra protocols or complex setups to talk to other parachains. It's just there. Much smoother for developers building cross-chain apps within Polkadot.
So just like with Cosmos, what's fascinating is how these parachains specialize, right? Each doing its own thing, but under that shared security umbrella.
Exactly. It fosters this really diverse ecosystem.
Let's look at some examples. What kind of parachains are out there?
Okay, a really important one is Moonbeam.
Moonbeam. What does it do?
It's an Ethereum-compatible smart contract platform. This is huge because it means developers can take their existing Ethereum dApps.
Apps already running on Ethereum.
Yeah, and deploy them onto Polkadot with very minimal code changes. It's like a super convenient bridge for Ethereum apps and users to access Polkadot's ecosystem, its scalability, its shared security.
Without a total rewrite. That's powerful.
Very powerful. Then you have Acala. Think of Acala as a dedicated DeFi hub built for Polkadot.
Like a one-stop shop for Polkadot DeFi.
Kind of. It offers a stablecoin, a DX, liquid staking derivatives, those tokens representing staked assets that you can still use elsewhere.
Keeping capital efficient.
Exactly. And all of this has native cross-chain functionality using XCM. So you can easily use assets from other parachains within Acala's DeFi services.
Okay. Other one.
HBAR network. This one's interesting because it supports both WebAssembly WASM and the Ethereum Virtual Machine, EVM.
WASM and EVM. Why is that good?
WASM is seen as a next-generation high-performance format, while EVM is obviously where most current smart contracts live. Supporting both gives developers maximum flexibility in how they build apps that can interact across the Polkadot ecosystem.
Catering to different developer preferences and future-proofing, maybe?
Sort of, yeah. And one more, Centrifuge. This one focuses on tokenizing real-world assets.
Real-world assets, like what?
Things like invoices, real estate, trade finance documents. Centrifuge works on bridging traditional finance onto the blockchain.
Bringing off-chain value on-chain.
Exactly.
Yeah.
Using Polkadot security and interoperability to make these traditionally illiquid assets accessible to DeFi.
So Polkadot is great for interaction inside the ecosystem. What about connecting outwards to Ethereum, mainnet, or Bitcoin?
Good question. Just like Cosmos, connecting to external networks outside the Polkadot shared security zone still requires specialized bridges.
So that external connection is still a work in progress.
It's an area of active development, absolutely. Building secure and reliable bridges to networks like Ethereum is crucial for Polkadot's wider reach, and they are definitely working on it, perhaps even exploring ways to connect with systems like IBC down the line.
Okay, so we've got these two really powerful but quite distinct approaches. Cosmos, the network of networks, big on independence, sovereignty.
Right. Each chain secures itself, connects via IBC.
And Polkadot, the blockchain of blockchains focused on shared security through the relay chain and parachains.
Connected via XCM, inheriting security.
Fundamentally different philosophies aiming for a similar goal, interoperability. So how do they really stack up against each other? Let's try a direct comparison.
Yeah. Understanding the trade-offs is key. Because the inevitable question people ask is, which one is better?
Right. Is there a winner?
And the answer, almost always in tech like this, is it depends. It's not really about better or worse. It's about different philosophies, different design goals, different trade-offs. Each is optimized for different things.
Okay, let's break down those differences. First up, architecture.
Cosmos. Truly a network of independent chains or zones. Each is sovereign. Polkadot. A central relay chain with dependent parachains. Parachains rely on the relay chain.
Got it. Independent versus dependent structure. Next, security model.
Cosmos. Each chain secures itself. They need their own validators, their own economic security, maximum autonomy here.
Yeah.
Polkadot, shared security via the relay chain. Parachains essentially rent security from the main network. Easier launch, less burden.
Autonomy versus shared security. That leads right into sovereignty, doesn't it?
Absolutely. This is a core philosophical split. Cosmos offers full chain sovereignty. Chains control their own destiny, upgrades, rules, fees, everything. Complete independence.
And Polkadot.
Polkadot offers limited sovereignty within its framework. Parachains are sovereign in their specific function, but they operate within the rules of the relay chain for security and consensus. They depend on that central layer.
Full versus framework sovereignty. Okay, what about flexibility? How customizable are they?
Cosmos chains are highly customizable. The SDK gives developers enormous freedom to build truly application-specific blockchains, optimized exactly how they want.
Total control over the design?
Pretty much. Polkadot chains are also customizable, very flexible, but within parachain specifications. They need to conform to the relay chain's interface to connect and get that shared security. Still flexible, but within certain bounds.
High customization versus customization within specs. Lastly, integration effort for interoperability.
For Cosmos, chains must implement IBC to connect. It involves integrating the module, setting up channels. There's some work involved.
You have to actively connect.
Right. For Polkadot, interoperability is built in for parachains once they connect to the relay chain, usually via winning an auction slot. Communication using XCM is native. Less setup needed for internal cross-chain stuff.
Opt-in connection versus built-in connection for parachains.
So putting it all together, Cosmos really prioritizes sovereignty. It's for projects that want total independence, full control, even if it means handling their own security and then connecting via IBC.
Maximum autonomy.
Maximum autonomy. Polkadot, on the other hand, emphasizes security and seamless integration by design. That plug-and-play security model is very attractive.
But it comes with constraints.
It comes with some constraints on chain design and that dependency on the relay chain in return for the built-in security and easier internal composability.
So the choice depends on project priorities.
Exactly. Do you value ultimate autonomy and control above all else? Maybe Cosmos is a better fit. Do you value out-of-the-box security and seamless built-in interoperability and are okay with operating within a larger framework? Polkadot might be the choice. Both are valid, powerful paths towards a multi-chain world, just with different trade-offs.
All right, we've covered Cosmos and Polkadot, both focused on connecting blockchains to other blockchains. Now let's explore a third solution that plays on a slightly different field, and honestly, one that maybe doesn't get as much hype in the pure crypto discussions, but its potential impact could be massive. That's the Interledger protocol, or ILP.
ILP, yes, it's got a different, broader mission.
Right. Unlike Cosmos and Polkadot linking blockchains, ILP focuses specifically on value transfer across diverse networks, and the key word there is diverse.
Yeah, it's not just about blockchains.
Exactly. It includes blockchains, sure, but also traditional financial systems, banks, mobile wallets like M-Pesa, payment processors. It aims to connect all of them.
Bridging the old world and the new world of finance.
And here's where it gets really interesting, their core analogy. They call it the TCP/IP of payments.
That's a bold claim, but it captures the vision perfectly.
Think about TCP/IP for the internet. It just works. It lets any computer talk to any other, regardless of OS, hardware, network. It made the internet universal.
The invisible plumbing.
Right. ILP wants to do that for money. Make sending value as easy and invisible as sending an email, no matter what system the money is starting on or ending up on. Ledger-agnostic value transfer.
And its design actually mirrors the internet's packet switching approach, which is why that analogy works so well. It makes it uniquely suited to bridge that gap between TradFi and crypto.
How does it actually work then, mimicking the internet?
Okay, so it breaks payments down into tiny independent packets. Just like data on the internet, these packets get routed across different networks. The key parts are connectors. These are the routers of the Interledger network. They sit between different financial networks, maybe between a bank and a blockchain, or two different mobile money systems, and they forward these payment packets. Critically, they don't typically hold the funds for long, minimizing risk.
Just routing the packet.
Exactly. Then there's packet switching. Like internet data, payments get broken into small, atomic packets. They're routed independently. If one path is slow or broken, packets can find another way. It makes the system efficient and resilient.
Smart. What about settlement? How does the money actually settle?
That's independent settlement. This is a key trust and security feature. Each hop, each segment of the payment path between connectors settles separately and atomically.
Atomically meaning all or nothing?
Yes. You only need to trust the connector you're directly interacting with, not the whole end-to-end path. If one segment fails, only the funds in that specific hop are affected, not the whole payment. It's very fault-tolerant.
Much less risk than trusting a single bridge operator with the whole amount.
Precisely. And finally, adaptive routing. Just like the internet finds the best path for data, ILP can route payment packets around failures, congestion, maybe even tricky regulatory spots. If one connector goes down, the payment finds another route. Reliability.
So it really is built like the internet, but for value packets.
That's the core idea: resilient, adaptable, ledger-agnostic value transfer.
What's really compelling here is the potential reach, right? Because it's focused on that payment layer and designed to work with existing financial systems.
Its compatibility is its superpower in many ways. It's not trying to replace banks, it's trying to connect them to each other and to the new world of blockchain.
So how does this translate into real-world impact? What can ILP actually do?
Okay, several key areas. Banking integration. ILP is designed to plug into traditional banking systems, often using established standards like ISO 2022. This could mean truly seamless transfers between crypto and regular bank accounts, a huge pain point solved.
Direct crypto to bank payments globally. That would be huge.
Potentially, yes. Then there's mobile money. In places where mobile money is huge, like with M-Pesa in Kenya, ILP can integrate. It bridges those smartphone payment systems to global networks. Think remittances, cross-border commerce for millions.
Connecting the previously unconnected.
Which leads to financial inclusion. This is a massive focus. Organizations like the Bill and Melinda Gates Foundation are backing ILP efforts. Why? Because it can connect local mobile money systems in underbanked regions to the global grid.
Bringing financial access to people left out by traditional banking.
Exactly. Enabling cross-border payments much cheaper and faster than old methods. The potential social impact there is enormous.
And it works with blockchains, too.
Yes, absolutely. It's compatible with multiple blockchains like the XRP ledger, Ethereum, others. And crucially, it facilitates that cross-chain value transfer without needing complex wrapping or those vulnerable bridges we keep mentioning. It aims to move the actual value atomically across ledgers.
So ILP might have a lower profile in, say, crypto Twitter hype cycles.
Yeah, you don't hear about it as much in pure DeFi circles, maybe.
But its potential impact, connecting TradFi and crypto at that fundamental payment layer, could be incredibly far-reaching.
It really could. It might become that invisible plumbing that just makes global payments work better for everyone, uniting these currently separate financial worlds. An unsung hero, perhaps. Okay, so we've covered a lot of ground. 3 distinct, powerful approaches to interoperability. IBC for sovereign chains and Cosmos, Polkadot's shared security model, and Interledger's broad payment focus, each with its own philosophy, its own strengths.
Let's try to bring it all together. How do they stack up across some key metrics looking at them side by side?
Good idea. Let's compare them. Ecosystem size and maturity. Right now, IBC probably leads here. The Cosmos ecosystem is mature, lots of active chains, significant volume flowing via IBC. Polkadot's ecosystem is growing fast, lots of parachain activity, but maybe still smaller in terms of number of live, independent chains compared to Cosmos. Interledger's crypto ecosystem is smaller in terms of volume and specific developer adoption, but its reach into TradFi is significant and growing.
Okay, so IBC strong internally. What about connecting outside their own worlds, external compatibility?
Here, Interledger really shines. Its whole purpose is connecting diverse networks, especially traditional financial rails. That's its unique strength. IBC and Polkadot both still rely on developing specialized bridges for external chains like Ethereum or Bitcoin. That external connection is less native for them.
Got it. Technical maturity and resilience. How battle-tested are they?
The 3 are quite mature, actually. IBC has handled huge volumes reliably. Polkadot's Relay Chain and XCM are well-tested and audited. Interledger, developed over many years, is very mature for its specific payment routing job. They're all serious technologies.
Good to know. Developer adoption and community.
IBC and Polkadot both have really strong, active developer communities building within their ecosystems. Lots of innovation. Interledger has lower adoptions specifically within the crypto dev space, partly because its focus is broader, but its adoption by fintechs and banks is a different story, quieter, but potentially very impactful.
And finally, transaction volume and value flow. Where's the money moving?
IBC shows very high volumes between Cosmos chains. That billion-plus monthly figure is real activity. Polkadot's internal XCM volume enables complex dApps, also significant, though perhaps less raw token transfer volume reported than IBC. Interledger's crypto-specific volume is lower, but its volume in TradFi and cross-border payments is where its real scale lies, often outside the crypto market's direct view.
So when you lay it all out, it really doesn't look like there's one clear winner, does it?
Not at all. There's no single best solution overall. IBC is fantastic for sovereign chains talking within Cosmos. Polkadot offers incredible security and built-in interop for its parachains. Interledger uniquely bridges crypto and TradFi at the payment level. They excel in different domains.
Which strongly suggests the future isn't about one protocol taking over everything.
Exactly. It points very clearly towards a multi-protocol future.
Specialized layers for specialized jobs.
Precisely. You'll likely use different protocols for different types of connections. It's not either. The complementary ecosystem emerging.
Which leads to a fascinating thought. Could we see these different protocols actually working together? Cross-protocol collaboration.
I think that's almost inevitable. We'll likely see gateways, adapters, connectors being built so that, for example, value can flow from a Cosmos chain via IBC, maybe hit an Interledger connector and settle in a bank account, or interact with a Polkadot dApp via a specialized bridge.
Weaving them together.
Weaving together this truly interconnected web of value and data. That collaboration will be crucial.
And that kind of robust interoperability, that's surely going to speed up institutional adoption, right?
Without a doubt. Traditional finance is dipping its toes into blockchain, but they need this stuff to work reliably and securely. They need these bridges, these communication layers, to be rock-solid infrastructure before they commit serious capital on operations.
Interoperability removes a massive barrier for them.
A massive barrier of risk and complexity.
And ultimately, for all of us, for you, the user, the end goal is it just works, a seamless user experience.
That's the dream. The vision is that eventually you'll move assets or use data across chains without even realizing it. No more wrestling with bridges or wrapped tokens or different gas fees.
The complexity just fades into the background.
Like the internet today, you don't think about TCP/IP when you watch a video. Blockchain needs to get there. This whole interoperability landscape is moving incredibly fast, and understanding these different approaches, IBC, Polkadot, ILP, really positions you well to see where this connected future is heading. Hashtag outro. You know, if we connect all this back to the big picture, the path to real blockchain interoperability isn't about finding one single magic bullet. It's clearly about building this complex, multi-layered system.
Different tools for different jobs.
Exactly. IBC, Polkadot, Interledger, they're all vital pieces of that puzzle, playing different but equally important roles in connecting blockchains to each other, and just as importantly, connecting them to the traditional financial world.
Which does raise a pretty profound question, doesn't it?
It does. As these protocols mature, as they maybe start working together more closely, how does that seamless web of value change things? Not just how we use crypto, but how global finance itself operates. Could we see a truly decentralized and interconnected global system? The implications are just vast.
Yeah, huge implications for trade, finance, identity. What stands out to you from today's deep dive into this intricate world of interoperability? What other questions does it spark about where we're headed?
Hopefully it provided some clarity.
We really hope this exploration gave you a fresh perspective, maybe some valuable insights into how these complex systems are evolving to be more user-friendly, more secure, and ultimately way more impactful. Join us next time for another deep dive, helping you become truly well-informed.